Hello everyone, welcome to Unacademy, India's largest online learning platform. Good evening Satish, good evening Raviteja, very good evening. Good to see you again today. I'm feeling very happy. Actually, I was down with fever, but after seeing your messages, I am actually energized. Your interest makes me so happy uh, to forget my fever and start teaching for you guys. Seriously, yeah, seriously, I'm not joking. I'm not telling all these things just for the sake of this thing. Actually, I'm down with fever today, but still, after looking at your wishes, evening wishes, just wanted to do a lot for you, right? Yeah, thank you. So let's start discussion. We have something called electronic devices and circuit subject. Today we'll be discussing about semiconductor physics, sixth part. The semiconductor physics, sixth part. Okay, today's sixth, and then this will be useful. I'm Shravan Kumar, as you guys know. I have a master's degree from JNTUH in VLSI system design. I have a GATE 10 plus years of teaching experience, and I can handle a subject like EDC, analog electronics, digital electronics, and EMFT. And I have a special code for you guys, that is uh, SVS 10, which will give you 10% discount on Unacademy Plus subscription. Unacademy Plus subscription. Then we have something called Plus subscription. The Plus subscription thing, but you can attend all the live classes. You can attend the crash courses. We'll be having weekly tests. So writing weekly tests is very important. So please do this weekly test. Attend this weekly test. Okay, and we have something called doubt solving session. Every fourth hour is going to be a doubt solving session for you guys. And somebody who don't understand English, they can attend the sessions in Hindi. So we'll be having sessions in both English and Hindi. And we have something called rank improvement batch. We have something called rank improvement batch, which will help you to get a very good rank in GATE 2022. Okay, and we have iconic subscription along with the benefits of plus subscription. We will be given you will be given a personal coach, and you'll be having a study planner. You'll be given a study booster sessions, and there will be something called personalized test analysis, and a preparatory study material will be available for you guys. Preparatory study material will be available for you guys. Okay, and we have something called plus subscription for 12 months. It's going to be 27,225 rupees after using the code SVS10. Plus subscription after 18 months. For 18 months after using SVS10 code, it's going to be 34,650 rupees. Plus subscription after for 24 months is going to be 39,600 rupees after using SVS10 code. And we have iconic subscription for 12 months. It is going to be 45,224 rupees after using the code SVS10. And iconic subscription for 24 months after using the code SVS10, you'll get 67,600 rupees. Guys, this 10% discount is valid till the midnight of valid till 28th Feb only. 28th Feb only. After that, we will be this percentage will go down to 5%. This percentage will go down to 5%. So please hurry up. Please hurry up to get this. Please hurry up to get this. Okay. And how to do it, sir? You know, most of you know, but it is my duty to tell you. So go to the Play Store, download Unacademy app, install Unacademy app. Then you will be taken to. You will be asked to choose your goal. You'll be asked to choose your goal. So select GATE and ESE as your this thing. Then click on plus subscription. Then get subscription. Then you will be taken to choose whether 12 months or 24 months. Then depending on your interest, you choose it. And don't forget to type SVS10 code. Don't forget to type SVS10 code and click on apply. And then you will be getting 27,000 rupees as a fee structure. And you will be taken to last things all payment method. You can pay using debit card, credit card, EMI, UPI, wallets, and net banking. Whichever you want, you can pay it, sir. Whichever you want, you can pay it. Okay. Yeah. So here comes today's important discussion of the theory of the energy band theory of crystals. So, if you permit me, I'll take 2 minutes of time to go back and see what we have discussed in the previous class. To go back and see what we have discussed in the previous class. So, if you look at what we have discussed in the previous class, our discussion was on electronic structure of elements, and then it means we have discussed about what are the four quantum numbers which are required to represent. Harika, good evening. Harika, good evening. Four quantum numbers N, L, ML, and MS, which they represent the shell, subshell, and our magnetic momentum, angular momentum, and the spin of an electron. Achiever, good evening. Achiever, good evening. And we have discussed about the Pauli's exclusion principle says that no two electrons in an electronic system will have the same set of quantum numbers. And then we have discussed about electronic shell. So n value for each n value ranges from 1 to 3 to the infinity, and each n value will be given some other English letter, that is K, L, M, N, O, P, Q, like this. So we have given this electronic shell. And then we have discussed about subshell L, which will represent the angular momentum. So S, P, D, F, G, H, I, like this we have seen. What is this L value? L value ranges from 0 to n minus 1. 0 to n minus 1 is the range of L value. And then if you see ML is ranges from 0 to plus or minus L, and MS will be always plus or minus 1 by 2. Plus or minus 1 by 2 is always plus or minus 1 by 2. Okay. And we have seen this in detail, how they are spreading, right? So what is AS, what is SP, what is SPD, SPDF, like this. What do you mean by n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4? So this is what we have discussed in detail in the previous class, right? And we've also seen what is each shell contains. Each shell contains how many number of subshells you have, and then what is the maximum electrons in each subshell, and then total how many electrons can be given in the subshell. So according to I think yesterday Raviteja mentioned that it is going to be 2n square. Exactly what is that? The total number of electrons in each shell will be represented by 2n square. The maximum number of electrons in a shell is going to be 2n square, where n represents shell number. Okay, so you can see here, if the value of n is increasing, so the values will be increasing, right? So the maximum number of electrons which can be accommodated in that shell will be increasing. So if the k is equal to 1, we have seen in detail 2n square. 2n square. Just a second. I just wanted to increase the clarity of my mobile structure. Okay, yeah, now I got it. And we have seen this is 2n square, which is very, very important. And we have seen, so here comes, if you look at the electronic configuration of this. So if you look at the carbon and carbon, silicon, germanium, and tin. So this is going to be 2n square, 2s2, 2p2, 3s2, 3p2, 4s2, 4d2. This is correct actually. 4p6, after 4p6, then you will be having 5s2, 5p2. 5s2, 5p2, we have 4d10. After 4d10, we have, this is not there. So simply we have a 5s2, 5p2. All outermost orbits have 4 electrons in their outer orbit, in the outer shell. So we can call these as tetravalent atoms. We call them as tetravalent atoms. So we can also call them, these are the fourth group elements. See how in an elements table, how all the groups are divided is based on their valency number of electrons. Based on the valency number of electrons, they are divided. So the monovalent is called first group, divalent is called second group, trivalent is called third group, tetravalent is called fourth group, pentavalent is called fifth group. Right? If you look at the complete elements chart, if you look at the element charge, so they are divided based on this. They are divided based on the outermost shell number of electrons. The number of electrons in the outermost shell will define which type of element it is, whether it is a tetravalent element, trivalent element, pentavalent element. So penta means always 5, always 5. So based on this concept, based on the number of electrons in the valency shell, so we call them fourth group elements. Now if you look at here, these are all having 4 electrons, so we call these as a fourth group element. We call them as a fourth group element. Sir, why our focus is more on the fourth group elements? We will discuss, sir. Because these silicon and germanium are the most important semiconductors, which are the heroes of our complete discussion of electronic devices. If you recollect from the day one, what we have discussed is electronic devices is a circuits in which the electrons flow will happen through a semiconductor. If you remember the concept, if you remember the name, so completely based on this, our importance is the silicon and germanium plays a major role in electronic devices. In electronic devices, this plays a major role. So because of that, our focus has come to this, right? Fourth group element. Of course, we'll come to trivalent and pentavalent also, but basically our more focus is on silicon and germanium. Basically, our focus will be on silicon and germanium. Is the point clear? Is the point clear? I think till this point we have discussed in the last class, and I think we are now supposed to start today's discussion. Yeah. So now here comes the energy band theory of the crystals. So this is very important. Pay attention for the next half an hour. Don't go anywhere. Don't go anywhere, at least for the next half an hour. So please pay attention for the next minimum half an hour. Even if you get some calls, don't attend all the calls. Just pay attention here. If you understand today's subject, today's topic, you will be more satisfied. You will be more satisfied of something called energy band. Energy band. Why the concept of energy band has come, how it has grown. So, and even you can explain it to your fellow friends that in detail, what do you mean by an energy band? What do you mean by an energy band? Okay. So that is what very important. That is what very important. Now you can see here, most metals are and semiconductors are crystalline in structure. So what do you mean by crystalline in structure, sir? A crystal consists of a space array of atoms built up by regular repetition in 3D. So if you want to know what you mean by crystal, so just let me explain you here how they look like. Just give me some time. Just give me some time so that I will explain you. So what do you mean by the crystalline structure of this? Crystalline structure of this. Hope you might have studied in the first year of your engineering also. The first year of your engineering, that is the semiconductor. I think some colleges or some universities will have subject called solid state physics. I don't know whether you have studied that solid state physics or not, but it is my duty here. Now I'll explain you. So consider a cube. Consider a cube, and to each corner of the cube, assume that one electron is existing here. Here we have one electron, here one electron, here one electron, and here one electron, here also one electron, here one electron. All the corners will have some electrons. All the corners will have some electrons. All the corners will have some electrons. Right? Now each corner element will share some bond with the other element. It means now don't think that only this. Here this electron will have some bond. We'll come back to this bond concept of covalent bond and the valency band. Covalent bond concept and ionic bond and covalent bond concept will come back. But just remember, this electron will have a bond with other electrons also. So if you consider this as a structure, this kind of structure will be repeated. This kind of structure is repeated. So the statement what is trying to make, the statement what is trying to make in the first is nothing but you have this. You have this kind of structure in a semiconductor material. In a semiconductor material, you will be having this kind of structure, and this will be repeated. It means you will have some more bond with the some more electrons here. You will be having one more electron maybe here, one more electron maybe here, one more electron maybe like this. So you may have many number of bonds, and these electrons might have their bonds with some other electrons also. So this kind of structure will be repeated. They are crystalline in structure, and it is repeated in three-dimensional. It is in the three-dimensional. It is in the three-dimensional, right? So when the atom of the crystals, it is found that the energy levels of the inner shell electrons are not affected appreciably by the presence of the neighboring atom. So if you look at previous discussions, so what we have done, sir, we have considered only one atom, and we have seen how it has to be in electrons. But in a given material, in a given material or a molecule, there are more number of atoms will be there, right? So you will not have only one atom. So you will be having many number of atoms will come together to form a molecule. Many molecules will form a material, right? So far we have considered only atom. Now consider a molecule which will be having more number of atoms, right? It means, so you will be you are bringing more number of atoms together so that it will become a molecule. Now I assume, so what will happen now what will happen? This is very important, sir. This is very important. Let me tell you. So now whenever these atoms are coming together, see the innermost shells will not be affected by. So just a second. If you think this is an atomic structure, what we have discussed, this is too much. Just a second, yeah. Just give me time. Let me draw another circle which is bigger than this, so that I can explain you what is the concept of this. Right? So assume that there are some electrons. This is a nucleus. Assume that this is going to be a nucleus, and you have an electron here, electrons here, electrons here. You may have electrons here and electrons here. The electrons here. Remember all the time. The electrons which are very close to the nucleus, these electrons which are close to the nucleus will be tightly bonded. Shivkumar, you can have a predictor. You can use a predictor. That's actually, congratulations. First of all, congratulations. Your score is very good score. 70.33 is a very nice score, which is very satisfactory score. But I can't predict the rank, but you will be having very good rank. First of all, congratulations. From my side. I don't know what you want to do, whether you want to go for your MTech or you want to pursue your PG or you want to go for a job. I don't know. But that's actually a good score. 70.33 is a very good score. You can use the rank predictor. I think there are some other organizations also which are giving you a rank predictor. They will help you a lot rather than an individual who can give me. Because it's all, as you know, it all depends on the, as you know, it depends on the percentile, not on the percentage. It depends on the percentile, not on the percentage. Okay. So first of all, congratulations. Okay. Yeah. Now see here. So these electrons which are very close to the nucleus, will be tightly bound to the nucleus when compared with these electrons. These electrons are not tightly bonded to the nucleus because they are far away from the nucleus. So the electrons which are far away from the nucleus are not tightly bonded, but the electrons which are very close to this will be having very are tightly bonded to the nucleus, right? Okay. So unfortunately, the power has gone. Unfortunately, the power has gone. Let us discuss how much time is possible. We will discuss that. Okay. So hope the power will restored as early as possible. Okay. Now what here he says here. So the outer shells of the outer shell. This is going to be shell actually. Outer levels of the outer shell electrons are changed considerably, right? So the energy levels of the outer shells. This is going to be a shell actually. I think I did not forget to write this. So All India fifth rank. You may get it. You may get it, Shivkumar. Advanced congratulations. Advanced congratulations. So the levels of the outer shell electrons are changed considerably since these electrons are shared by more than one atom in the crystal. So whenever these electrons or the outer shell electrons are shared by another atom it means so you'll be having like this, sir. So this and this may be shared. So these electrons may be shared. So the outermost electrons may be shared by some other. So this is also another nucleus. So this electron may be shared by these two atoms. So their energy levels will be. Krishnaveni, good evening. It's been long time, Krishnaveni. Hope your exams are completed. Hope your exams are completed. So these electrons are shared by the atoms. When these electrons are shared by the atoms, their energy levels will not be same. Their energy levels will not be same. Right? So shared by electrons, and new energy levels of the outer electrons found that coupling between the outer shell's electrons atoms result, and that is called a band. Now just see here what I'm saying. Just see here now I try to explain you in detail. I'll try to explain you in detail. So what I mean by all these things. What I mean by all these things. Okay. So consider n number of electrons. Consider n number of atoms. Right. So whatever he says here is so by considering n number of atoms, so each atom consists of, let's say, consider this 2s2 2p2 carbon, no 2s2 2p2 or 3s2 3p2 silicon, 2s2 2p2 or 3s2 3p2 you can consider. 3s2 3p2 is a silicon. So now in this, so how many electrons are there, sir? 4 electrons are there in the outermost shell. So let's consider n number of electrons, n number of silicon atoms, n number of silicon atoms. So if we consider n number of silicon atoms, capital number of silicon atoms, good Krishnaveni. I'm feeling very happy about. I'm feeling very happy about your feedback. Hope my classes helped you a lot. Seriously, did they help you? Yeah. Thank you, thank you. Okay. Consider n number of silicon atoms. So n number of silicon atoms means so how many number of see this is going to be 3s2, each atom is having 3s2 3p2 electrons. It means so 2 into n electrons of s orbital is 2 into n number of electrons of p orbital, right? Yes. That's good. That's good, Krishnavan. That's good. Okay. So 2n electrons of s orbital and 2n electrons of p orbital are there. If you consider n number of silicon atoms, so each s orbital and p orbital will have their own energy levels. Each s orbital and p orbital has their own each s orbital and p orbital have their own energy levels. So if you consider that, now I'll tell you here. So here you consider, now on x-axis you consider such a beautiful concept. With this is hope the power will be restored as early as possible so that I can discuss it is in detail. Hope I am running on right now. I am running on. That's good, Krishna. That's good. That's good. I am running on power supply. Let's see, the power will be restored as early as possible. Okay. So now consider, obviously these two will be having two different energy levels. So 2n states. So if you look at here, as I told you, it will be having 2n electrons of s orbital, 2n electrons of p orbital. Sir, actually, how many number of electrons can an s orbital will have? S orbital can fill how many electrons, sir? It can fill 2 electrons. So I can say it has two states. Each s orbital can fill 2 states. And what about p, sir? P is having a probability of filling 6 electrons. Yes or no? It can have six states are available. 6 states are available, but out of 6 states, only 2 electrons are available here. Satish, you are right. Satish, you are right. Satish, you are right. Satish, you are right. So 2n states of s orbital and p has 6 states. The p has 6 states, but out of which here you have only 2 electrons, but 3 has a complete field. S orbital is completely filled, but p is still, there are empty states. P has some empty states. So what I am saying here is, so this is the energy level of p orbital. This is the energy level of s orbital. So which is having 2n number of filled states. 2n number of filled states. Here, but in this case of P, so 6n number of states are there. 6n number of states, out of which only 2n states are filled. 2n states are filled. Yes or no? 2n states are filled. So this n indicates number of electrons, number of atoms. So please pay attention here. Don't get confused. So this is, let's say, some distance between the atoms. This is going to be energy states. This is going to be energy. This is going to be the energy. Okay. So you have 6n number of states and 2n number of filled states. 2n number of filled states. No, sir. I think the power is going up. So please, we'll continue the next class. I'm sorry. The power has gone. Power is not going to restore. So thank you. Please like the video. Please like the video and share the video. Right. So please like the video and share the video and subscribe it. Once the power restores, I think I'll take extra hour if possible. The extra hour if possible. So I'll take extra hour in next class. I'm sorry. The power is disturbing me a lot. I have run the complete story for 10 minutes. I think I thought the power will be restored, but unfortunately the power did not restore. So in the next class, I'll discuss this is in detail. If possible, I'll take extra 30 minutes tomorrow. Right? If possible, I'll take extra 30 minutes tomorrow. So you need not worry. I'll finish off this syllabus. This is actually an interesting concept, sir. This is actually an interesting concept. This is a very interesting concept to be covered. Unfortunately, the nature is not allowing me to complete it. Right? I'll do it. I'll do it. I'll take extra 30 minutes tomorrow. Okay. Thank you. Thank you. Bye. Take care. Right. We'll catch up in tomorrow's class. Luckily, the power has restored. Luckily, power has restored. So don't, please don't go, sir. Don't go. Yeah. Very happy that power has come. At the end of this moment, the power has come. The nature has listened to us. The power has come. The power has come. So don't go. Satish, please be online. So the power has restored. The power has restored. Yeah. I'm feeling very happy about it. I'm feeling very happy. That was very worrying thing. That is a very worrying thing for me. That's good. That's good. You waited till the end of this. So okay. So 6 in number of states and 2 in number of states are filled. Out of 6 in number of states, only 2 in number of states are filled. So but here we have 2 in states and 2 in electrons. So we have actually 2 in number of states, and then here we have 2 in filled states. Now, let's say it's going to be a first state. And if you see the second stage, what I'm trying to do is, I'm trying to decrease the size of this. Let's assume that initially this size is, the size of the gap between each atom is, let's say, so 10 micrometers, 10 picometers or 10, example I'm telling, sir. Example I'm telling you. So assume that is going to be 10 micrometers. In the second step, I'm trying to decrease it to 5 micrometers. If I'm trying to decrease it to 5 micrometers, so what we'll get, sir? We'll get like this. I'm just trying to write it here in the here itself. So that so now the size is decreased. Now it has come to 50% of the previous one. It has come to 50% of the previous one. So nothing has changed. Nothing has changed. Nothing has changed. But what happens is the distance between these two atoms is decreased. When the distance of the two atoms is decreased, now see what is going to happen. This is the very important concept. This is very important concept to be considered, sir. Very important concept to be considered. Now, when these two atoms are coming together, now what's happening, sir? Their energy levels will be. So this has 5 micrometers. So earlier it was 10 micrometers, and here it considered as 5 micrometers. Their energy levels will overlap each other. So what do you mean by that? So this I can call interatomic distance. Interatomic distance. Interatomic distance. Right now we will see. So what is going to happen if the interatomic distance is decreased? So till this, assume that this is going to be some 10 micrometers. This is going to be 10 micrometers. This is going to be 10 micrometers. Now it is decreased to 5 micrometers. Now we'll see what will happen. So this is very important. Please pay attention here. Now, when the interatomic distance is decreased to 5 micrometers, this is 5 micrometers. This energy level E, and then this is let's say distance is. Now slowly what's happening is here, their energy levels will be spreading. Like this. Their energy levels will be spreading, sir. So why, sir? So they are almost try to. So this here the energy levels are not spreading. They are separated. When the interatomic distance is more. So what do you mean by that, sir? So when in the atom, if the atoms in a given molecule, if the atoms are far away, so their interatomic distance is high, then there is no overlap at all. Now slowly what's happening here is this, because of this, now what's happening, sir? This area is spreading now, right? So the number of electrons the number of electrons can be changing here. So the interatomic distance is changed. So I'm saying this is going to be 5 micrometers. If this is going to be 5 micrometers, still you will have what happens, sir? This is the 6n states and 2n electrons, but still it is going to be 2n electrons only here, and here 2n states, you have 2n states and then 2n electrons will be there. Right, sir? In the third step, what I'm trying to do, sir, I'm still trying to decrease. Let's say I'm trying to come to 1 micrometer. 1 micrometer, interatomic distance is decreased. If still I'm trying to decrease the interatomic distance, if I'm still trying to decrease the interatomic distance, let's say I'm decreasing it to, so now if I'm trying to decrease, now what's happening, sir? They will touch each other and form a new energy level. So they are overlapped. They are overlapped to each other. And now what happens, sir? Earlier we have seen actually. So how many number of electrons? Sir, are you getting or not? This is very important. So this is very important. Please pay attention here. So if you look at here, this complete region I'm talking about. Hope you are getting what I'm saying. So now these energy levels are overlapped. Are you getting or not? What I'm saying? These energy levels are overlapped. If the energy levels are overlapped, now what happens here? Earlier in this case, you can simply define what are the electrons of P region and S region, S orbital, P orbital. This is P orbital, S orbital. But here you will not able to differentiate between what are the P orbitals electrons and what are the S orbital electrons. It means total energy levels will become 8 states, and then you will be having 4 electrons. Simply you will be having 4 electrons. Are you getting or not? Please let me know. Sorry, if you are unable to get, I'll repeat it. Just pay attention here. Assume that this is going to be 1 micrometer distance, 2 micrometers distance. 2 micrometer distance, and this is energy level. This is the energy level. Please reply me, sir. Are you able to understand or not? Here you have 2n electrons, 2n states of P region and 2n electrons, 2n states and 2n filled states. Yeah. So I'll do it for Riteja. I'll do it for you, Riteja. Just pay attention here. So what I'm trying to say here is, so initially when the interatomic distance is very high, interatomic distance is 10 micrometers, you will be having S orbital which is having 2n states and 2n states which are completely filled, right? It means, so if you have two electrons are there, you can fill in an S orbital, you can fill 2 electrons, all those 2 electrons are filled, this is 3s2. But in case of P, you have 6n possible states, but out of which only 2 electrons are filled. That is what I am trying to say here. So here for P region, for 2n states, all complete 2n states are filled, but in case of P, you have 6n states, out of which only 2n states are filled. Now what I am trying to do, sir, I am trying to decrease the interatomic distance, the distance between these 2 electrons. Let's say this is going to 1 atom, this is going to 1 atom. If I am trying to decrease, earlier this I considered this as 10 micrometers, and now I am considering the atomic distance, the distance between 2 atoms. I brought it very close. So that it becomes 5 micrometers. Now if it is 5 micrometers, now what's happening, sir? The energy levels of these P and S start spreading to each other. Means they are coming close to each other. It is very difficult for you to identify. Which which energy state belongs to which orbital. You will not be able to find out. You will not be able to differentiate between the energy states of P and energy states of S. But if you still further decrease, if you still further decrease, now what is happening here is, in this case, the 2n electrons you will be able to find, the 2n electrons will be able to find, the 2n electrons will be able to differentiate between S and P. But here, the complete states are coming together and becoming a new energy levels. That new energy levels will have 18 states completely, 8 states, and out of which only 4 electrons are filled states. So here you have, actually I should write this is going to be 8n states, out of which 4n states are filled. 4n states are filled. Did you get the point now? Did you get the point now? 4n states are filled. Okay, so 18 states, out of 18 states, 4 electrons will be filled, 4 states are filled. So here you'll be able to differentiate, but here you will not be able to differentiate. So here 6n states of P and 2n states of S were there, but here you will not be able to differentiate. Total states are coming together. Total states are coming together and becoming a new energy state. Sir, what you are trying to do is, you are trying to still further decrease. If you are trying to still further trying to decrease the energy states, a new, now see, this is the beauty, the final stage of this energy E, and then this is going to be interatomic state D. Now what will happen here is, assume that the interatomic state has become, interatomic distance has become 1 micrometer. 1 micrometer. Now what happens here is, you will see here, so now till this point, what happens here? This 18 states, out of which anywhere the 4n states will be available. But here what happens is, these out of which only 4n states are filled, right? So all the 4n filled states will be, these are filled states, these are unfilled states, unfilled states, unfilled states. So all the energy levels which are having filled states will form a new energy level. New energy level. All unfilled states will form a new energy level. Try to understand this, sir. So here, in the previous case, you will be having 18 states, out of which 4n states are filled. But still, those electrons may be moving from one state to other state. But here now what happens, sir? All the filled states will form one energy level. All unfilled states will form another energy level. All filled states will form one energy level. All unfilled states are forms another energy level. Sir, now this filled state, it means how many electrons are there here, sir? How many electrons are there? So total will be having 4n states. Here you will be having 4n states. Here we will also be having 4n states. So here 4n unfilled states and 4n filled states. This filled states energy is nothing but valency cell, valency. And this unfilled states energy is called conduction, and this region is called the forbidden region, where you will not find any. This is called energy gap. Hope you got the point. Hope you got the point now, right? So initially, if the interatomic distance is 10 micrometers, so you will not have any problem. So 2n filled states of s orbital. Here 6n states of p orbital. Out of this 2n states are filled, and when this distance is decreased, slowly the energy levels will be spreading. So, but still they are not coming together, not overlapping. And but here at this point, when they overlap, total n 18 states will form, out of which only 4n filled states are there. If you still further decrease, now what is happening here is, Now what is happening here is, so filled state will form one energy level, unfilled states will form another energy level. Filled states form one energy level, unfilled states will form another energy level. This filled states are called valency energy band. Valency energy band. And this, the unfilled states are called conduction band. And the gap between these filled, unfilled states and filled state is called energy gap. Hope you got the point. Hope you got the point. Hope you guys got the point. Hope you guys got the point. Are still doubt you have? Do you have still doubt? Or is the point, is the concept clear? Harika, Satish, okay, very good, very good. Very good. So you got the point. So this is how the energy gap has formed, and this is nothing but a band of energies we call, right? So this is a band of energies called valency band. In this band of energies is called conduction band, and this gap of the energy band, the range of energies for which the electron will not exist. Either, right, these are very good. Either the electron should be in the state of filled state or in the state of unfilled state, but it can't be in between. It can't be in between, and that gap is called energy gap. That called is called energy gap. Okay, I think that is what he's trying to explain here. So the pre-atomic shell is going to be 6, and this large number of discrete but closely spaced energy levels is called an energy band. Energy band, right? So this is how an energy band is existing. This is how the energy band has created, right? So the upper vacant band is called, the upper vacant or unfilled energy state is called conduction band, and the lower filled state is called valency band. Lower filled state is called valency band. Upper unfilled state is called conduction band. Upper unfilled state is called conduction band, and lower energy state is called filled state is called valency band, and the distance between, the gap between these two filled and unfilled state is called energy gap, where electron will not exist here. You can also call this as a forbidden energy gap. Forbidden. The energy, the electron will not exist in this gap. The electron will not exist in this gap. That is the reason why we call it as a forbidden. It's going to be forbidden, and this is called as energy gap. This is called as an energy gap. So based on this concept, now we will define. Now based on this concept, now we will define any material into 3 types. So one is called insulator, second one is called metal, and the third one is called semiconductor. So what do you mean by insulator? A very poor conductor of electricity is called insulator. So what do you mean by this? Now you consider this. Now I'll try to explain here using the concept of the valency band. So now this is called valency band. This is called valency band, means filled states, and this is called conduction band. Conduction band. In between these two, what will be there, sir? In between these two, what will be, sir? You will be having an energy gap. You will be having an energy gap, Eg. This energy gap will be there. If this energy gap is 6 electron volts, if this energy gap is 6 electron volts and more than that, so there is no possibility of electron which is in the filled state can go to conduction state. It means, so you can see here, so the electron cannot jump from this state to this state, and this gap is very high. So understand, sir, whenever this gap is 6 electron volts and high, whenever this gap is 6 electron volts, 6 electron volts, then the filled state electron cannot go to unfilled state and cannot become free. Okay, and this energy gap, if the energy gap is very high, means the gap between filled state and unfilled state is very high. the gap between filled states and unfilled state is very high, that electron cannot move from this filled state to unfilled state, and that is called energy gap. So based on this energy gap, if the energy gap is 6 volts, the energy gap is 6 volts, and the electron cannot move from valency band to conduction band, then that is called an insulator. And it is a poor conductor of electricity. It cannot conduct electricity because you don't have a free electron. All the electrons are filled. All electrons in the filled state. All electrons are in the filled state. So you can't allow them to go to conduction band and do something. So because of that, we call it as an insulator. What are the examples, sir? Can somebody tell me what are the examples of insulator? Examples of insulator. Examples of insulator. This is having an energy gap of 6 electron volts. Can somebody tell me what are the examples of insulator? You know it, I think. Every day we use it. Wood, ceramic, plastic. Yes, you are right. I can call this as a wood, plastic, and one costly thing is there. One costly thing is there. Glass, correct. Glass is also correct. Glass is also correct. You can call it glass. And one very costly thing, diamond. Diamond is also an insulator, which is very costly. This is very costly. Okay, now then something called metal. The metal, right? An excellent conductor of electricity is called as a metal. But what do you mean by this? What do you mean by this, sir? The conduction band, the energy gap between frankly speaking, there is no energy gap. There is no energy gap. So they'll be looking like this. So this is unfilled state. This is unfilled state, and this is filled state. So the energy bands of filled state and unfilled states is the energy band of filled states and energy. So this is a valency band. From here to here, I can call this as a valency band. This is a valency band, and this is conduction band. This is conduction band. So these two are called as conductors, right? So whose energy levels are, what is the energy gap for this, sir? This energy gap is going to be 0, no energy gap at all. So in the previous case, the energy gap was 6 electron volts. The EG, I can call this simply EG. Remember from today, what is EG, sir? EG is going to be 6 electron volts. 6 electron volts. I should say this is going to be 6 electron volts, not volts. 6 electron volts. If the energy gap is 6 electron volts, we'll call it insulator. And if it is EG is going to be 0, VG is going to be 0, we can call it as metal. So easily the electron can move. There are more freely electrons will be available, which can move from one state to other state. That is from conduction to valence or valence to conduction. Right. Next, here comes our hero of the day. Hero of our discussion. So first statement which I am making here is this. So far what we discussed is complete basics of this semiconductor. Right? A substance whose conductivity lies between insulator and metal is known as semiconductor. Means now we will talk about this very clearly. In terms of energy gaps, we will talk about. Can somebody guess what should be the energy gap, sir? What should be the energy gap? This is the valency band. This is the valency band. This is going to be conduction band. Conduction band. Conduction band. So what should be the energy gap, sir? What should be the energy gap? Guess what should be the energy gap? If it is 6 electron volts and high, that's going to be the energy gap of a semiconductor is going to be simply 1 electron volt. It's going to be 1 electron volt, right? So based on this energy gap concept, the materials are divided into these things. One is metal, insulator, and semiconductor. It means the electron in the valency shell gain some energy of 1 electron volt, and it can go to conduction band. Either it is not at all a pure conductor, it is not a metal. It is not an insulator also. Right? So because of that, it is called semiconductor. Very important points to be remembered, that this is a semiconductor whose energy gap is going to be 1 electron volts. Means, so these are the filled states. From our previous concept, is called filled state, and this is going to be unfilled states. So electron can move from filled state to unfilled state. It means the gap between the filled state and unfilled state is going to be very simple, 1 electron volt. It's going to be 1 electron volt. Okay, 1 electron volts, right? So very important point to be covered based on this. Very takeaway points are there for semiconductor. So we will discuss about this semiconductor in detail in the next class. We'll discuss about this semiconductor in this next class. Okay. The orbital model of silicon atom also we'll discuss in next class. Right. So one thing you should remember, sir, time waits for no one. The takeaway, the important point to be remembered for today is time waits for no one. Speak to your heart before it's too late. Don't be afraid of the consequences. Start focusing on your goal. Please talk to yourself. Remember, time will not wait for anyone. If you are in the second year, if you are in the third year, if you are in the final year, or if you are still finished your game, I mean to say BTech, if you are targeting for GATE 2022, don't waste your time on unnecessary things. Focus on your goal. And you can't buy time. So my humble request is focus on this. Time is very important. And sir, first of all, you try your game. You may fail in the examination. That's okay, yaar. Don't worry about the consequences. But whether you are putting your efforts or not is important. Whether you are putting efforts or not is a very important thing. If you are putting your efforts, you will definitely get very good results. As somebody commented today, he says he got 70.33 marks. It has not come overnight. So he might have put lot of effort to reach there. So don't focus on unnecessary things. Focus on your important things. And time is very important for all you guys. So focus on time and plan accordingly in your life. Okay. And we have something called plus subscription. Plus subscription will give you live access to all the classes. You can attend all the crash courses. You will be there. You can write all the weekly tests, and you will be having doubt solving sessions. And sessions will be English and Hindi. And you will be having something called rank improvement batch. So what is the meaning of iconic subscription? Iconic subscription, nothing but you will be given a personal coach. You will be having a study planner. You will be given a study booster sessions, and a personal test analysis can be conducted, and you will be given a preparatory study material. You know the fee structure for 12 months, 27,225 rupees. For 18 months, 34,650 rupees. For 24 months, it is 13,600 rupees, right? For 12 months of GATE iconic subscription, this is going to be 45,000 to 24 months, 67,600 rupees, and you will be having something called SVS 10 as a code. This code of 10% will be decreased to 5% from the March 1st, right? So this 10% is valid till 28th February. So hurry up, please hurry up to get the discount. Okay, and all my class notes will be available on Unacademy GATE English Telegram channel. So please do join for Telegram channel of Unacademy GATE English. And I'm teaching on Unacademy GATE English channel. So you'll be having other channels also: Creatix GATE, Unacademy GATE, Mechanical Engineering for Civil Engineers, and Computer Science Engineers for Electrical Engineers, and GATE questions. So you'll be having all these channels will be there. So please, thank you for patiently listening to my class. We'll catch up in tomorrow's class. Plus, don't forget to like the class, share the class, subscribe the channel, and hit the bell icon. Thank you. Good night. We'll catch up in tomorrow's class. Thank you, Harika. Thank you, Raviteja. Bye. We'll catch up in tomorrow's